Good morning, my dear children. Welcome to the online class. First of all, we will recap whatever we learned in the previous classes. Representation of a set. There are three representations. Descriptive form. In this, we can give the set as words. Second one, set builder form. In this, we can give a rule. Third one, roster form. In this, we can give or tabulate the elements. Next one, types of set. Empty set. There is no element in the set. Singleton set. There is only one element in that set. Finite set. There are finite number of elements in the set. Infinite set means there are infinite number of elements in the set. Universal set. Under a consideration, collection of all elements will be said universal set. Equivalent sets. Two sets are equivalent if their number of elements will be same. Equal sets. Two sets are equal if they contain exactly same elements. Subset. If a set A is said to be subset of a set B, then every element of A is also an element of B. Proper subset means if you set A and B are proper subset, A is subset of B but A not equal to B. Power set. Collection of all subset said to be power set. Disjoint sets. If two sets are disjoint, there is no common element. Now let us see set operations. First one, complement of a set. The complement of a set A is the set of all elements of U that are not in A. Except elements of A, remaining elements in the set U are collected together, that is the complement of the set A. It is denoted by A dash or A complement. In symbol, A dash equal to set of all X such that X belongs to U but X doesn't belongs to A. Next one, see the Venn diagram. Here the shaded portion is the set A. Here the shaded portion is the set A dash. Except A, remaining of U will be A dash. A dash the whole dash will be A. U dash will be empty set and empty dash is equal to U. Union of two sets. The union of two sets A and B is the set of all elements which are either in A or in B or in both. It is denoted by A union B and read as A union B. How we read this? A union B. In symbol, A union B is equal to set of all X such that X belongs to A or X belongs to B. This is the Venn diagram for the set A union B. Here the sets A and B have common elements. The shaded portion is for A union B. If the two sets are not joined, that means they are disjoint. There is no connection. In this case, this is the Venn diagram for A union B. You have to shade A and also you have to shade B. A union A is always A. A union empty set also A. A union the universal set will be U. Here A is any subset of the universal set U. And A subset A union B also B subset A union B. A union B is equal to B union A. This is called as commutative property of set union. Next one, intersection of two sets. The intersection of two sets A and B is the set of all elements common to both A and B. It is denoted by A intersection B and read as A intersection B. This is the symbol for intersection. So, A intersection B. In symbol, A intersection B is equal to set of all X such that X belongs to A and X belongs to B. The elements should be lie in both the sets. This is the Venn diagram for the set A intersection B. The common portion of A and B will be shaded. if B is subset of A. That means B is fully inside of the set A. A union B will be the greatest set A. A intersection B will be the smallest set B. A intersection A is A. A intersection empty is empty. A intersection U is A. Here A is any subset of universal set U. A intersection B is subset of A, and also A intersection B is subset of B. A intersection B is always B intersection A. This is called as commutative property for set intersection. If A and B are any two non-empty sets, then A union B is equal to A intersection B when we get A is equal to B. Let n of A equal to P and n of B equal to Q, then minimum of n of A union B is equal to maximum of P and Q. Maximum of n of A union B is equal to P plus Q. Minimum of n of A intersection B is equal to 0. Maximum of n of A intersection B will be minimum of P and Q. These are, they may ask in 1 marks. Next one, difference of two sets. Let A and B be two sets. The difference of sets A and B is the set of all elements which are in A but not in B. It is denoted by A minus B or A difference B. How we read this? A difference B. In symbol, A minus B is equal to set of all x such that x belongs to A and x doesn't belongs to B. Suppose B minus A you want to find means set of all y such that y belongs to the first set B and y doesn't belongs to the second set A. This is the Venn diagram for the set A minus B. From A, whatever the elements of B you have to subtract. You have to eliminate. Next one. This is the Venn diagram for B minus A. From the set B, whatever the portion for A, that you need not shade. A dash is equal to U minus A. A minus B means A intersection B dash. A minus A is equal to empty set. A minus empty set will be A. A minus B and B minus A are equal if and only if A equal to B. A minus B is equal to A and B minus A equal to B when A intersection B empty. Next one, symmetric difference. The symmetric difference of two sets A and B is the set A minus B union B minus A. First you have to find A minus B and you have to find B minus A. At last you have to find the union of that differences. It is denoted by A symmetric difference B. A symmetric difference B is equal to set of all x such that x belongs to A minus B or x belongs to B minus A. This is for A minus B and this Venn diagram for B minus A, and now symmetric difference is union of these two. So union means this diagram and also this diagram. So join together. A symmetric difference A is equal to empty. A symmetric difference B equal to B symmetric difference A. A symmetric difference B is equal to set of all x such that x belongs to A union B and x doesn't belongs to A intersection B. A symmetric difference B is equal to A union B minus A intersection B. When seeing the Venn diagram itself, you can understood A union B, what are the portion you had. From that you have to subtract the common portion A intersection B to get the symmetric difference. Now, exercise 1.3, first question. Using the given Venn diagram, write the elements of A, B, A union B, A intersection B, A minus B, B minus A dash, B dash, U. So first one, you see, set A, first subdivision, set A. A is equal to, see, this circle is represented for A. So what are the elements in the circle that you have to write in a set? See here, 2, 4, 7, 8, 10. The elements of A are 2, 4, 7, 8, 10. Next, second subdivision, they are asking for B. The second circle is represented for B. So what are the elements in the circle you heard? They are the elements of the set B. See, 3, 4, 6, 7, 9, 11. 3, 4, 6, 7, 9, 11. Now, third subdivision, A union B. A union B means A and also B. So what are the elements? 2, 3, 4, 6, 7, 8, 9, 10, 11. 2, 3, 4, 6, 7, 8, 9, 10, 11. Now, fourth subdivision, A intersection B. Intersection means common portion elements. So, common portion is this one. So, elements are 4 and 7. Now, fifth subdivision, A minus B. So, listen. This is the circle A. So, in that circle, you have to eliminate the portion of B. So, what are the remaining you heard? 2, 8, 10. So, A minus B means from A, you have to eliminate B fully. So, what are the remaining? 2, 8, 10. Now, sixth subdivision, B minus A. So, from the set B, you have to eliminate fully the elements of A. So, the remaining elements are 3, 6, 9, 11. Now, the seventh subdivision, A dash. So, except A, remaining all the elements in the universal set are elements of A dash. So, what are the remaining elements except A? 1, 3, 6, 9, 11, 12. So, except A, remaining all the elements. So, 1, 3, 6, 9, 11, 12. So, A dash. Eighth subdivision, B dash. B dash means except B. Except B, remaining all the elements in the universal set. 1, 2, 8, 10, 12. B dash equal to 1, 2, 8, 10, 12. Now, the last subdivision, ninth one, universal set U is equal to all the elements. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. Now, we'll see the second question. Find A union B, A intersection B, A minus B and B minus A for the following sets. First subdivision, given the set A is equal to 2, 6, 10, 14 and the set B is equal to 2, 5, 14, 16. So, first you have to find A union B. A union B means the set 2, 6, 10, 14 joined to the set B 2, 5, 14, 16. So, you have to write all the elements in both sets and if any element is common, you have to write only once. See here, 2 is common, 14 is common. So you have to write 2 at once, then 14 also at once. So remaining 2, 6, here also 5. So arrange in ascending order. 2, 5, 6, then 10, then 14, 14. So you should write 1 time 14, then here 16. So this is A union B. Now A intersection B. A intersection B means common elements only. So A is 2, 6, 10, 14. Intersection B is 2, 5, 14, 16. So what are the common elements in those sets? 2 is common and 14 is common. So the intersection set is 2, 14. Now A difference B. A difference B or A minus B you can read. A, the set 2, 6, 10, 14 minus B 2, 5, 14, 16. Now see here, minus means from the first set what are the elements in the second set, those who are eliminated. So here 2 and 14 we have. So 2 and 14 should be eliminated. So remaining elements in the set A 6, 10 only. You need not consider the second set. You have to consider the first set only. So the remaining in the first set 6, 10. Now B minus A is equal to, what is the set B? 2, 5, 14, 16 minus, what is the set A? 2, 6, 10, 14. So what are the common elements? 2 and 14. So 2 and 14 will be eliminated in the first set. So remaining elements in the first set only your answer. So 5, 16. You need not worry about the second set. Only the remaining elements in the first set should be right as answer. Now the second subdivision. The second subdivision given the set A is equal to the set A, B, C, U, E and the set B is equal to A, E, I, O, U. Now we have to find A union B. A union B. The set A is A, B, C, E, U. Union, the set B is A, E, I, O, U is equal to, first you see A, here also A. So you write A once. Then B, C, then E, write once. Then U also once you write. Then what is the remaining? O. You have to write all the elements in both the sets, but each and every element occurs only once. A, B, C, E, U. A, E, I. So here you should write I. I, O, U. So all the elements from both the sets, but every element should occur only once. Now A intersection B. A intersection B is the set A, B, C, E, U. Intersection B is what? A, E, I, O, U. Now you say what are the common elements? A, then E, then U, U. So your answer is A, E, U. Now A minus B. A is the set A, B, C, E, U minus B is the set A, E, I, O, U. Now from the set, first set, what are the elements same in second? Those who are eliminated. So here A eliminated and E eliminated and U eliminated. So what are the remaining elements in the first set? That is your answer. The set B, C. Only you should write what are the remaining in the first set only. No need worry about the second set. Only you should write the answer remaining in the first set. Now B minus A. That means you should write first the set B. What is the set B? A, E, I, O, U minus. What is the set A? A, B, C, E, U. So now common elements, same element should be eliminated in the first set. So remaining elements in the first set is I, O. So B minus A. Now the third subdivision, given the set A is equal to set of all x such that x belongs to n natural numbers less than or equal to 10. So what are the natural numbers less than or equal to 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the set B is equal to set of all x such that x belongs to w. W means whole numbers, starts with 0 and less than 6. So from 0, 1, 2, 3, 4, 5. Less than 6 means previous number of 6, that is 5. So these are the two sets. So we have to find A union B. See here, A union B, we have to write all the elements from the set A and the set B. If any element repeated means you should write at once. So here ascending order I can write. So the starting number is 0, then 1, then 2, then 3, then 4, then 5, then 6, 7, 8, 9, 10. A union B. Now A intersection B. A intersection B is common elements of the two sets. So what are the common elements? 1, 2, 3, 4, 5. So the common elements are 1, 2, 3, 4, 5. Now A difference B. So A is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 minus what is B? 0, 1, 2, 3, 4, 5. So common element should be eliminated from the first set. So 1, 2, 3, 4, 5. So what are the remaining elements in the first set? 6, 7, 8, 9, 10. So this is the answer for A difference B. Now B difference A equal to, you should write B as first. 0, 1, 2, 3, 4, 5. Minus, what is the set A? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what are the same elements have to be eliminated? 1, 2, 3, 4, 5. So remaining element in the first set is 0 only. So B minus A answer is singleton set 0 only. Now the fourth subdivision, A equal to they given set of all letters in the word mathematics, that is M, A, T, H, E, again M, so only once you have to write, again A, again T, then I, C, S. Now the set B is equal to the set of all letters in the word geometry. So G, E, O, M, again E, so only once you should write, then T, then R, then Y. So these are the two sets. Now we have to find A union B is equal to, A union B means all the elements from both the sets and every element should occur only once. So M, A, T, H, E, I, C, S, comma, G, E already written, then O, then M already written, T already written, then R, then Y. So this is union. Next, intersection. Intersection means common elements. What are the common elements? E is common, M is common, T is common. So what are the common elements? E, M, T. So now A minus B. A minus B. The set A is M, A, T, H, E, I, C, S minus, what's the set B? G, E, O, M, T, R, Y. So, same elements from both the sets have to be eliminated from the first set. So, E have to be eliminated, then M have to be eliminated, then T have to be eliminated. So, remaining in the first set will be your answer. A, H, I, C, S. A, H, I, C, S. Now, B minus A. So, you should write B as first. B is G, E, O, M, T, R, Y minus. What is the set A? M, A, T, H, E, I, C, S. So, what are the common elements have to be eliminated? M, T, E. So, what are the remaining elements in the first set? G, O, R, Y. Hope you understood, children. Practice all the questions without fail. Practice makes a man perfect. So, practice a lot. Thank you, children.